Have you ever wondered how a swerve drive works?
How to efficiently wire your electrical system?
How to construct a robust pneumatic system?
Or how to use a running filter to denoise the input of the CMU cam for your PID closed-loop control system to aim a 3-axis of freedom turreted shooter during autonomous mode? Well, don't worry.
This is the Blue Lines, a show designed to show you all the tips and tricks to build a competitive robot. Throughout the season, we'll show you advanced techniques and give you an in-depth introduction to everything you need to know.
I'm Greg Maya.
I'm TBA, and this is the Blue Lines.
That was easy.
Here at the Blue Lines, we try to make it easier for everyone to start off on a level playing field by taking some of the simpler things put into competitive robot building and bringing them to you.
One of the things we always see on the Chief Delphi forums is people ask, how do the electronics in my robot work?
See, that's a very important thing, because if you can't get your electronics to work, you don't have a robot. So actually today, we've brought a little box of tricks. And everything in this box is what's going to help you get your kit robot up and running. Today we've laid out the Innovation First control system. If you're on a first team, this is most likely the controls you'll find in your kit of parts come January.
Right, this is all the stuff that makes your robot go.
Yeah.
So starting from the very beginning, you have your robot battery. Now we don't actually have one of those here with us, but the first thing it does is it goes into this fuse panel. The fuse panel controls all the major motors and anything that's going to be drawing a lot of current on your robot, so you want to make sure you don't short the battery, which is really bad.
Once again, for those of you on first teams, in your kit of parts you will find two fuse panels. You'll find this bus that will do 20 and 30 amp fuses, and you'll find another one, a car audio fuse box that does 40 amp fuses.
Tom, why would I need 40 amps? It seems like a lot.
Well, see, actually, you would want to run 40 amp fuses for your drive motors. You know, last year the sim motors and the mini bike motors, those ran on 40 amp fuses. And 20 amp fuses go to things such as your robot controller or smaller motors, solenoids, stuff like that.
Cool.
So the next thing we have here is the robot controller. This is probably the most essential part of the robot. This is a little bit of an older model, about circa 2003. You'll find one that's a little bit different in your new kit, but the features really haven't changed, so I'm going to go over a few of them. Up here on the top we have PWM outputs. This is a pulse width modulation output that's going to drive your motor controllers. Over here we have analog and digital inputs. What you're going to be able to do here, analog inputs, you're going to be able to hook up different analog sensors, such as the gyro, accelerometer, potentiometers. And digital inputs, you can hook up switches or photo...
banner sensors?
Yeah, banner sensors, photo switches, stuff like that. Down here we have our relay outputs. That's going to hook up into this little baby, a spike relay. And those will just turn on or off. And you're going to be able to set your team number down here as well.
It's important.
I believe on the new ones, on the new robot controllers, you only set the team number in one spot, and it syncs it via tether.
But you got to know your team number in binary.
Ah, yeah.
Do some math.
And see, this actually works on a 12 volts here, which comes from a 20 amp fuse. And there's a program port that you're going to hook up your computer to program the robot. There's a tether port. You can use a serial cable to hook up to your control board, so you can control the robot without using a radio. And there's a port for a radio. So, the first thing I mentioned was these PWM ports. Let's move down the line to this Victor speed controller. Now what we have here is a speed controller. This will actually take a constant power input, and based on the signal it gets from the robot controller, will modulate itself to drive a motor. So the way this works, because it could be a bit confusing for people who haven't seen it before, is in your actual program, your code that you write to drive your robot, you're going to set a variable, a PWM variable, to a certain value. This value is going to be from 0 to 255, with 127 right here in the middle as neutral.
Indeed.
So Greg, do you want to comment on how that works a little more?
So basically, since you're programming in programming language, the computer doesn't really know what a negative number is. So in order to do negative numbers, you pretend that 127 is your new 0. So numbers above 127 correspond to positive values, and the more positive it is, the faster it will drive the motor from 0 volts all the way up to 12 volts. 12 volts being full speed forward. Then you can also put in numbers below 127, which will correspond to negative values, all the way down to 0, which will give the motor negative 12 volts, driving it in reverse at full speed. This is a spike controller. It's essentially a relay, so it has 3 states: forwards, off, or backwards. There's a couple different things you can control with the spike controller. Usually what teams use it for is to power the pneumatic pump compressor on their robot in order to pressurize their pneumatic systems. You can also use it if you want a motor that's only going to drive full speed forward or only full speed backwards for a turret or something like that. But usually you're going to want to use a Victor speed controller to have more fine control over the robot's motion.
Greg, you also might want to mention that if you're using a pneumatic system, this is what's going to be hooked up to your solenoids, or solenoids as we like to call them here in Connecticut, to power your pneumatic pistons.
That's right. One way will power them forward, the other way will power them off. And in fact, you can get 2-stroke solenoids that will let you do multiple strokes. That's when you would use the reverse channel on this. In order to control all of these things, of course, we have our trusty PWM cable. This is essentially normally used for hobby airplanes, but we use it to carry signals to and from our different sensors and motor controllers on the robot.
As you can see here on the spike, simply just plugs in. You have a B and a W, stands for black and white. Plug in the corresponding colors. This one's bent, so I can't do it, but there it goes. And this just hooks up to the robot controller. You're all set.
Next up, we have a motor. Now this is kind of an older motor, so Tom, you want to explain that?
Sure, this is actually a globe motor. My favorite motor. Is it your favorite?
I like the Big Sims.
The Big Sims? Well, this is a good motor. And on every motor, you will find a positive and a negative lead. And pretty much what you're going to do is hook up the positive lead to the M plus on the Victor speed controller, and the negative lead to the M minus on the Victor speed controller. Those will be clearly labeled or in a spec sheet, so you should be able to figure out how to do that on your own. And the motor will drive.
This is the radio modem. One of these goes on your robot, and then a similar modem goes on your operator interface. The two talk to each other based on your team number, so make sure it's set correctly on both sides of your robot. In order to set the team number on your operator interface, you have to actually hook it up to the RC, tether the two, and then they both make sure that they know what team they belong to. Some teams like to put the radio up high on the robot to make sure that it has a strong communication, but usually that's not necessary. One important thing to make sure is that you don't use the radio while you're in the pit. Use a tether cable to talk to your RC, because if you use the radio, it'll be on the same frequency as robots on the field, and you might accidentally start controlling someone else's robot.
Yeah, that actually happened once. It wasn't good.
No, it's bad. The last piece of the FRC control system is the operator interface. This is where you hook up your joysticks and any custom controls that you build to allow your drivers to control the robot on the field. It's hooked up to the radio, which communicates to the radio on the robot for communication. Also on this operator interface, you have what's called a dashboard port. If you choose, you can hook up a laptop computer or Palm Pilot to the dashboard port and get information in real time from the robot for diagnostic purposes. This can be a real use when you're developing your robot and trying to test if your code is working. So we've just reviewed the fundamentals of the electrical system for a first competition robot. Now you have a better idea of how to wire and construct your electrical system.
Please remember, whenever you're working on your robot, wear your safety glasses, because you won't want to get hurt.
That's very true. If you have any questions, comments, or suggestions for the Blue Alliance, or a topic that you'd like to see covered and better explained, email us at questions@thebluealliance.net.
Right here. It's right here.
Also, be sure to check out the show notes for this show, because we'll have more wiring schematics and other electrical information that you can use when assembling your robot. Also, don't forget the white paper section of Chief Delphi, which is linked to on our page.
So, I'm Tom.
I'm Greg,
See
and
you
this
next
is the
time.
Blue Alliance.